Hi there, I hope you are all fine. Today we are going to look at numerical methods. Numerical methods is one of the big topics in mathematics paper 2 of A-level. And it deals with appropriate methods that are used to find appropriate solutions to some mathematical problems. So under here we shall look at linear interpolation and extrapolation. So under linear interpolation and extrapolation, relationships of variables which are linearly related can be handled here. With linear interpolation, the value of a variable lying between two consecutive values can be calculated using linear interpolation. So with the linear interpolation, the value of a variable lying between two consecutive values can be calculated. With the linear extrapolation, a value that lies before two consecutive values or after two consecutive values can be calculated using linear extrapolation. Now, when you are dealing with linear interpolation and linear extrapolation, the idea of gradients between two points is employed here. We should know that the gradient of any two lines, between any 2 points lying on the same straight line is the same ground. That's why we have a statement that a straight line has the same or a constant gradient. Let's have an example. Given the table of values x and y below. Here we have x, we have y. Given the table of values of x and y below, this is the table. Then they're asking that using linear interpolation or extrapolation, estimate number 1 the value of x when y is equal to 55. Number 2 the value of y when x is equal to 60. Now, before we answer, we have to know whether we are going to use linear interpolation or extrapolation, and we can discover that by looking at the positions of the required value which you're supposed to find. So back to the table. Roman number 1, they need us to find the value of x when y is equal to 55. These are the values of y, and 55 is the value that lies between 50 and 70. 55 is the value that lies between 50 and 70. So we are going to extract this part here. 55 lies in there, and we need the value of x up here. So let me extract this part here with the 55 in the middle, and the x is what is supposed to be found. Solution, we are going to extract. Have x, have y. So from our table we have the value of x there being 30, and the value of y, corresponding value of y is 50. Then here we have this side 46 and 70 here, and we know that 55 lies in the middle there between 50 and 70. Then we need to find the value of x. You should also remember the note which we had, that linear interpolation and extrapolation use the knowledge or the idea of gradients. So I'm going to have A, B, C. I'm going to assume these points being on a straight line. So if they are on a straight line, like that one, if I call this is point A, point B, point C, the gradient between AB is equal to gradient between AC. So I have grad AB is equal to gradient AC. We know that gradient is change in y over change in x. So I'm going to start. This is my second point, my first point. So I'm going to have 55 minus 50 divided by, we're now looking at AB here and here, x minus 30 is equal to gradient AC. So we are going to get the gradient between the 2 points A and C. So I have 70 minus 50 minus 50 over 46 minus 30. So when you subtract here 55 minus 50, you get 5 divided by have x minus 30, giving us this is 20 all over 46 minus 30, you get 16. Cross multiply, this is going to be 20 x, then plus minus 600, giving us 80. So when you solve for x, x is going to be equal to 34. So if we have to look at x values, they are here. We need to identify where 60 lies. So 60 lies beyond 50 here. So there we are going to use linear extrapolation. So when we are using linear extrapolation, we are going to take two consecutive values. So we are going to chop from here and we create another one this side. This is where 60 lies and we need to find y there. So I'm going to extract this. So let's extract. Have x, going to have x 46, 50 and 60 here. Then y, they are corresponding. We have 70, we have 90, and I have y, a, b, c. Still, we are going to use the same knowledge that the gradient between AB is equal to gradient between AC. Why they are linearly related. Things which are linearly related can be represented on a straight line. So let's have that. Gradient AB is equal to grad AC. So this is the A, this is the B. So I'm going to get the gradient between these. So I will have 90 minus 70 divided by 50 minus 46, giving us gradient AC. This is C, this is the A. So I have y minus 70 divided by 60 minus 46. So when you subtract here 90 minus 70, you get a 20 divided by 50 minus, you get 4 here, giving us y minus 70 divided by 14. So when you cross multiply, here you're going to get 4y minus 280, giving us 208. So when you simplify here, y is going to be 140. So that is our first example. We have seen how linear interpolation and linear extrapolation works. Now linear interpolation, to be specific, is going to be used in finding the roots, as we're going to see. Now the process of dealing with it is going to be the same, but when it comes to finding the roots, there is something very special that we are going to include here. We need to keep with me. Let's get the next example. That will be in the next lesson. But example number 2, in an experiment, the following were recorded. So we have a table here, which I'm going to draw. So here is our table. Values of t are here. They want us to use the linear interpolation to find, Roman numeral 1, theta when t is equal to 16. Roman numeral 2, t when theta is equal to negative 1. So the steps are the same. We are going to first of all identify where our given value lies. For example, in Roman numeral 1, t, which is equal to 16, lies between 12 and 20. You can see these values are increasing, going this side, theta when t is equal to 16. So let's have an extract. So I have t here, I have theta. 16 is here and 20. But the corresponding values for 12 and 20 are there. So here we have 2.9. Here we have negative 0.1. We need to find, I call this A, B, C. Now, we know that gradient, still using the idea of gradient, gradient AB is equal to gradient AC. So A is here, B is here. So we are going to get the gradient. I will have theta minus 2.9 divided by 16 minus 12. giving us, now we are going to find the gradient AC. A is here, C is here. So let's start. We started with the theta values on the numerator. So we have negative 0.1 minus 2.9 divided by 20 minus 20. So this is the same as theta minus 2.9 all over 4 being equal to negative 3, negative 0.1 minus 2.9, get negative 3 divided by 8. So when you cross multiply here, we shall have reducing by 2 here, shall have 2 theta minus 5.8, have reduced by 4, get 1 by 4, 2. Cross multiplying, this is why we are coming up to this, is equal to negative 3. So when you simplify, theta is going to be 1.4. That is theta. So we have found theta when t is equal to, Roman numeral 2, we are going to find t when theta is equal to 0, negative 1. First of all, we have to identify where negative 1 lies, and we base on that by extract. So here I have my t. Now negative 1, theta being negative 1, this is theta. Now negative 1 lies between negative 0.1 and negative 2.9. But what are the corresponding values of t? We have here a 20, and I have got here that. So we need to find that t. I can call this is a b. Still, I will say gradient AB equal to gradient SC. Then this is A, this is B. So we get the gradient. It will now be negative 1 minus negative 0.1 divided by t minus 20 is equal to gradient SC. This is A and this is C. So this is negative 2.9 minus negative 0.1 divided by, we have that minus 20. So when you do that, in the numerator here, this is negative 0.9 divided by, this is t minus 20, giving us, this is negative 2.8 here, divided by 10. Cross multiplying and solving for the value of t, you'll find out that t is actually equal to 23. T is equal to 23. So this has been purely linear interpolation without mixing. So we have another example before we do some exercise. Given the table below of values of x and the corresponding values of x squared. Our table is here. I have 3.35, 3.36. Corresponding values here have been 11.223, 11.290. They need us to use linear extrapolation. Find 3.363. Now, when it comes to this, please don't just get a calculator and you press. They said that you use linear extrapolation. So you need to know what that means exactly before you work it out. Here you realize that they squared. They got 3.35 squared. They gave us 11.223. So when you look at this table here, these are the values of x, which when you square x squared, you'll get this. So what does it mean? It means this value here is a value that corresponds to x. Likewise, this corresponds. So this lies in the row of x. So we see that x now is 3.363, is a value that lies beyond here. You can see that this shows a trend that they're increasing, going to this other side. So I'm going to extract and I will have a table like this. So when I extract my table, this is how it will. Again, I'm going to put here my A, B. We need to find the x squared, not by pressing the calculator, but by using the knowledge of linear extrapolation. We know that we are dealing with linearly related variables. So if something is linearly related, that means it can be drawn in a straight line, and the gradient between any 2 points that lie on the straight line is the same. So that's why we are going to say gradient AB is equal to gradient SC. A is here, B is here. Let's get the gradient. I have 11.29, 0 minus 11.223 divided by, we have 3.36 minus 3.35, giving us again gradient S. So it's going to be x squared minus 11.223, everything divided by 3.363 minus 3.35. So that is what it means by getting the gradient. So when we get a calculator there in the numerator, 11.290 minus 11.223, you will get a 0.067 divided by this minus that, you get 0.01, giving us, when you get this one remains the way it is, x squared minus 11.223 divided by this minus that, you will have to get 0.013. So when we cross multiply there, we shall have 0.01 x squared minus 0.01 times 11.223, you'll get 0.11223, giving us that minus that, you'll get 0.000871. So from here, when you make x the subject, x squared, when you make x squared the subject, x squared is going to be equal to 11.3101. So that is to 4 decimal places. So this is what we do when it comes to using linear extrapolation. Next, we are going to have a trial number. So we're going to have here our trial numbers. The table below shows the values of temperature theta at different times capital T. But a theta, when capital T is equal to 370, when capital T is equal to 720, capital T, when theta is equal to 70 degrees, we need us to find T when theta is equal to 38 degrees Celsius. So that's our number 1. Number 2, the second trial number. The table below shows the values of x and their corresponding values of fx. So this is the table of values of x and their corresponding values of fx. This is 3.88, 5.11, 8.14, 11.94, 12.23. They need us to use linear interpolation or extrapolation to determine is equal to 2.15. Number 2, need us to determine the value of x when fx is equal to 0.10.7. At times, this can be set as a 2.15. It means the same. It means that the value of x is 2.15. You locate where 2.15 is in our table there. Remember, those are our 2 trial numbers. We are not limited to this. However, we can go ahead and look out for more questions of the same nature from other sources. It can be even the question bank, can be past papers, whatever the source can be, provided you do more numbers of this. Don't forget to subscribe with me. It is only through subscription that you can be notified of the new videos that I make.